Hi, my name is Ryan Slay, and this is my final project for DSS 65R programming. And I start my project by reorganizing the files from my data set into a more manageable format. And then I take that data to create some interesting charts using ggplot2 and gganimate. So jumping right in, we can see on the right that I have an NFL data set containing 30 CSV files broken out across 6 seasons. And each season contains 5 documents, one per position, so we have defense, quarterback, and so on. Now, it's going to be quite cumbersome to try to bring all that information to R and keep referencing 30 different variables as I create the charts. So the better approach is to condense those 30 files into just 5 lists, one per position. So I'm going to do that by first copying each file into a single folder that I call all data. And when I do that, I'm going to rename the files so that it keeps the number of the season from which it came. And that's going to allow me to create some interesting charts later on in the project. So to do that, I'm first going to create the folder using this code here. If you look to the right, it's automatically going to create the new folder, which I thought was just so cool we could do from RStudio. Open that up, you see it's empty, but as soon as I run this bit of code here, it copies the files and uses the format that I was speaking to previously with the season and then the original file name. So it looks good. However, I noticed that the capitalization is inconsistent between files. For example, DEF is all lowercase here, the D is capitalized here. I want to go ahead and fix that. We'll use this format where just the first letter of each file is capitalized. So I'll run this bit of code. It's not going to change right before our eyes since we're in the folder, but as soon as I exit out and come back in, we see that everything worked nicely and everything is now consistent. We can also confirm that over here in the R console and see that this matrix I created, the defense, is consistent across every season. So we've now reorganized the files in our folder, but we actually need to bring that information into R. So we're going to use the read.csv function, and I'm going to bring all 30 files into a new variable called data full, which is a list of 30 lists. Now it's pretty messy look all at once, so we'll just take a look at the first list, which is the 2012 defense. We see it looks like everything pulled in correctly, so that is great. However, we need to go ahead and change the names because the names of each list in data full are actually the full path file. And that's going to make it very hard to reference in later code. All I really want is just the season and the position. And I can get that basically with the directory function of the new folder we created, all data. However, it's going to include that .csv in the name, which I don't really want. So I can load the string R library and go ahead and replace the names. So I'll go ahead and do that. And then we'll check again the data full names using the names function. And we see, yep, everything is now named correctly without the .csv, so this is perfect. Now, the next step to combine the data is we want to use this bind_rows function. But in order to do that, we need to make sure that the attribute counts are consistent for a given position. So for example, all the defense files need to have X number of attributes in order to bind correctly. So I'm going to create this new data frame called df, which is an index for the various properties of each file. So I'll run that bit of code. And when we do that, we can do a manual inspection and see that, yes, the 2012 defense has 13 attributes. The 2013 defense has 13 attributes. And it would be pretty easy to see everything matches up. However, it's still pretty manual. The better approach is to use the by function that we learned in class and create this bit of code right here. And we way more easily see that all the attribute counts line up across positions. So we're good to go from that standpoint. However, the next step is we want to go ahead and bring all the different position files together. Right now, you see that everything is organized by season when really we want it organized by position. And so I'm going to create an alternate version of this data frame called df reorder. And it does exactly what I just spoke of. Now all these file names are listed by position. However, this is just an index showing us various properties of each file. It doesn't actually hold any of the information. All that information is still in data full, and data full is still in the order of the original read.csv. So if I look at the names, we see instead of having the 2013 defense as the second list, it's still in the order where 2012.qb is the second list. However, we can use this index, and because the file names are the same between df reorder and data full, we can use this code to say, hey, I want you to look in df reorder, look at this file name, find these file names in data full, and order data full in this same order. So that's exactly what we're going to do. And then when we recheck data full using the names function, we see that it's exactly what we want. Now 2013.defense is the second list, and it goes subsequently with the rest of the defense position list. So this is perfect, exactly what we want. Now we get to the grand finale, and by using the tidyverse function and the bind underscore rows, we can combine all of the defense data into just one list. And when we do that, I'm also going to keep the season from each observation and put that in a new column. And again, that's going to allow me to create some interesting charts later on. So I'll run this code and we'll take a look at some of the list right now. So running, creating, and we see, yep, everything looks pretty good. And now instead of just 30 files, we have 5 files. So it's perfect, exactly what we want. Now, technically, we go ahead and start making the plots using ggplot2. However, I also want to go ahead and put this data in CSV files so that I don't have to run this code every time I open up a new instance of RStudio. So if you look to the right, just like before, I'm going to create a new folder called combined data. And over here, we see now combined data has been created. I open it up, it's empty. But as soon as I run this bit of code and use the sapply function, it automatically writes all the information we just combined into new CSV files, and it's way cleaner than with what we started. So really happy with how it turned out and was really excited to learn we could do this in R. So now moving to the second part of the project, let's first inspect the data using the glimpse function. So I'll run this code here. We see that most of the attributes are integers or numeric, and that's good. It allows us a lot of opportunities to create different combinations for graphing. However, one thing we will want to look at, whether we're doing a statistical analysis or creating graphs, is look at the missing data. And one way we can do that is with the VisDat library. So I'll load that, and we'll take a look at the third list, which is the running back data. And I liked the VisDat library because it showed us which observations had values of NA. So we see we have NA values for rushing average, reception average, and yards after carry. And I wanted to take a closer look at that, and I found an observation with NA values for all 3 variables. And so running this code here, we see that what happened is whoever originally created this data set, they took the average for these attributes for every player, whether or not they had rushing yards or reception yards. And when you do that, you divide by 0, and that results in this NA value. So this leads me to believe that the validity of the data set still holds. We can still use it for our analyses. However, I just need to be cautious if I decide to use these attributes in any of my graphs. If I do so, I'll just need to be sure to remove those NA values so that I'm getting the results that I want. So the first graph I'm going to look at, and I'm going to zoom out here, is the quarterback data. And I'm going to create a new variable to hold all that information. And that way I'm not having to continually subset into this revised data. Just going to make it a little easier to bring into ggplot2. So create that. Now, one thing we need to remember is that we just combine many seasons of data into just one list. And because of that, if a player's been in the league for a little bit, they're going to show up as multiple observations. So we can use Tom Brady as an example and see that, yes, he shows up as 6 observations in our new list. And this data format can be useful for trying to track the performance of a player over different seasons. However, I may just want to see what is Tom Brady's overall QB rating average, or what is the sum total completions that Tom Brady has thrown. And that's what I want to do here, and I can accomplish that with the dplyr library. I'm going to take the sum and the average of the various columns to create a new variable that I'm going to call QB summary. And what I want to look at in this first graph is I want to see if a quarterback's average touchdowns are related to their average quarterback ranking. So I'll create this new variable here, load the dplyr library, and then use ggplot2 to go ahead and create that graph. So I decided to include the simple linear regression model. We can see that the slope is positive and it's statistically significant at the 0.05 level. We see some of the big names from the NFL: Aaron Rodgers, Tom Brady, Drew Brees in the top right. So it seems that average touchdowns is at least somewhat related to the average quarterback rating, which is makes sense. It's not the end-all be-all deciding factor, but it does hold some weight. Now for the second chart, I'm going to create basically the same graph, except instead of grouping the data by names, I want to go ahead and group it by team. I'm interested in seeing which teams historically rostered the most effective quarterbacks. However, instead of just showing the team name, I want to spice things up a little bit and include that team logo using the gganimate library. So run basically the same code, and then if we look to the right, it's going to load all those team logos in the graph, which I thought was really cool. I did not know we could do that in R originally. I just think it looks so crisp and so slick. Some things of note is, remember before that we saw players such as Aaron Rodgers and Tom Brady on the top right? But when we do the teams, their respective teams are also in the top right. Green Bay Packers for Aaron Rodgers, the New England Patriots for Tom Brady. However, in the first graph, we noticed that Peyton Manning is a top tier quarterback, yet his last team, the Denver Broncos, has slipped in that second graph. And we see that it's gone down and to the left. And the reason for that is because those top tier quarterbacks have been the franchise quarterbacks for so long that other backup players likely weren't considered in the average. But Peyton Manning was only part of the Broncos for a few seasons. And they probably had some backup quarterbacks that were just bringing that average. And we can actually see that by creating a nice looking chart using the GT library. We could just output that data up here, but GT allows us to make a nicer looking chart, which I found really useful. So we can look at the chart and see, yes, exactly what I was talking before. Drew Brees and Tom Brady were the only quarterbacks considered for this analysis. However, if we go down to Denver, we see, yes, they have Peyton Manning, but they also include Kyle Orton, Tim Tebow, and Brock Osweiler, which have some very bad quarterback ratings and was bringing down that team average. So moving to the next graph, I want to go ahead and also consider quarterbacks, but I want to see their average rushing yards per season and then their average rushing touchdowns. So I'm going to run this variable here to compile that information. And then I'm going to display that information using a lollipop chart, which I found out is really just a fancy way of combining geom, column, and geom point. However, note that when you're creating the chart, you need to put geom point after geom column. Otherwise, the column is going to overlap the point. It's just going to look off. So looking at the chart, we see that quarterbacks historically don't run the ball that much, usually less than 300 yards per season on average. However, two quarterbacks seem to be in a league of their own, which is Cam Newton and Russell Wilson. They average 600 rushing yards per season, which is just an insane amount. However, even though Russell Wilson has about the same rushing yards as Cam Newton per season, Cam Newton scores far more touchdowns. And this tells me that they're both good in the open field, but Cam, with his bigger body and he's more muscular, he's more likely to take the ball on himself, take that punishment, and get his team a touchdown. Another thing that's interesting is that somehow Peyton Manning has negative rushing yards. Many other quarterbacks have 0 rushing touchdowns on average, but somehow Peyton Manning went negative. So this means that he's probably very slow and needs a very good offensive line in order to keep his team competitive, since it seems like he cannot rush out of pressure. So moving forward, I want to go ahead and now look at a team's rushing and passing yards holistically. And I'm going to get that information from the wide receiver and the running back information. So I'll put all that information together into a new variable that I'm going to call pass rush. And when I do that, we see that each team has a single observation and a column for passing and a column for rushing. Now, I could go ahead and create my chart, which is going to be a dumbbell plot, and with the information in this format. However, we learned in class that the better way is to use the reshape2 library and the melt function. And that's because this format, while it's good, it just requires you to create additional geom functions in your code, which we want to avoid if we can. So I'll go ahead and use that library. And then if we look at pass rush once again, we see now that each team has 2 observations, a single column telling me what play type, either rush or pass, and then those original values that we saw before in just the yards column. So now I will plot the dumbbell graph using this code here. And then we see that New England is very good at passing the ball. We can see that in this top right here, which makes sense. We found in a previous plot that Tom Brady is a top tier quarterback. And then we also see that the Cleveland Browns are very bad at rushing the ball. I was able to highlight that with this translucent rectangle using the annotate function. Also note that I used 2 geom line functions, and the second one was to give each dumbbell that nice shadow effect. I thought it made it look just a little bit slicker and stand out. So I'm really happy with how this graph turned out. Now, this graph is very interesting and allows us, again, to see a team's holistic rushing and passing yards over all of our data. However, it might also be interesting to see which teams have improved over the years. Maybe one team was really good at rushing the ball for a given season, and then the next season they dropped dramatically. And I can do that by plotting the information using gganimate. So I'm going to create basically the same variables that I did before, except instead of just grouping the data by team, I'm also going to group it by season. So I'll go ahead and create that information now. And when I got to this step in the previous graph, remember I used the melt function to combine that data into the pass and rush column and the values over here. I tried that originally, but then it turns out gganimate has a problem forming certain polygons with a geoline function. Just wasn't working out, so I did some research and found this ggalt library, and it actually has this function called geom dumbbell. And because of that, it has these attributes x equals and xn equals, which allows a user to define the start and the end of each dumbbell. And therefore, I don't have to use the melt function, and I'm not causing additional steps. So I'll go ahead and load these libraries. I'm not actually going to run the code below just because it takes about 40 seconds for each chart to render. I've already loaded those here. So we can see that the chart's automatically moving. The season changes so that the user knows which data they're looking at. The rush and the passwording goes back and forth. So it's really slick. I know it might not be rendering at a high speed for this video since I'm using Zoom, but trust me, if you run this code yourself, it looks very, very good. Some things to note about this chart. Somehow Cleveland scored negative rushing yards one season, which I don't know how they did. Atlanta had almost identical passing and rushing yards in 2015. So it probably made it very difficult for other teams to play defense against them since they really couldn't guess which type of play they were going to run since Atlanta was effective at both. So I had a lot of fun making this chart and thought it turned out really, really well. And then the last chart for my project is going to look at the tight end information. So I wanted to see how the top tight ends, how many touchdowns they're scoring each season. So I compiled that information. For some reason, the tight end data set did not have a single column for all their touchdowns. So I had to sum the reception and the rushing touchdowns. No big deal. Just pulled that information all together here. And then I found that Gronkowski, Graham, and Gates were the top tight ends within our data set. So I created a new variable that pulled in just their information. I also decided to include the team logos that we created earlier and put that in the chart. So I'll run this bit of code right now. And then again, I'm going to use the gganimate library. I'm not going to run the code because it takes about 40 seconds to render, and I've already pre-populated that chart. We see that it's tracking each of these top tight ends touchdowns throughout the years. It has the logos on the right going up and down, looks very slick, keeping the user engaged. I tried to match the line colors with the team logos. So New Orleans has this gold, Chargers have this yellow, and the New England Patriots have this blue color. We see that Gronkowski was a beast in 2013, scoring so many touchdowns, but then he fell off in 2014, 2015. I don't know, maybe he was hurt. Had a bit of an increase, and then still a top tier tight end within the NFL. So again, had so much fun creating this chart. I was very impressed about how much we can accomplish in RStudio, especially gganimate, and I'm excited to use this in the future. So that wraps up my project. In summary, I learned a lot doing this project, especially learning how to reorder and rename folders directly from the R console. I think that's going to be such a useful skill to have as I continue my career and start looking at really big data sets. And then as far as things that can be improved with the data I use for this project, I would have loved to also have had each player's height and weight throughout the years. I'm interested in seeing our teams historically drafting different players of different weights, different sizes, or maybe running backs getting heavier throughout the years, and how does that affect which teams are winning. I would also like to see team salaries and player salaries, because I know when a player is first drafted, they have to be with the team for 3 seasons. However, then they can renegotiate. So I'm interested in seeing which statistics are most highly correlated with those high renegotiation contracts. So that wraps up my project. Thank you so much for listening. I learned so much about R programming this semester and had a great time. Thank you so much, and I'll talk to you later. Bye.